Hey, Algebra 2. Sorry I couldn't be here today. I had a dentist appointment again. So, fair warning, don't chew ice when you're younger. Just telling you now. I just want to give a shout out before we start to Jordan and Amanda, who finished their coordinate plane activity, and they actually checked their answers on the calculator. So that was awesome, guys. And then I want to give a shout out to, and this isn't everybody, so I apologize, but to those people that did their vocab last Friday in preparation for this lesson on function notation and interval notation. That would be Kevin, Brianna, and Blake, and Jules, as well as Mason and Logan. And there's probably some others. I'm sorry if I forgot you. So you can get after me when I come back tomorrow. So we're going to go over 2-2, characteristics of relations and functions. I'll tell my sub, please hit the pause button because I have to talk really fast on these so that they will upload correctly. Remember, now the difference between relations and functions. Relations and functions are almost exactly alike in that they can be they can use coordinates x, comma, y, or x, comma, f of x, which is that function notation we're getting in today. They can be used and shown with a graph on the coordinate plane. A relation and function can. And they can use a table with an input and output of x, comma, y, or x if you want to use f of x, no function notation. We'll get into that today. But the big defining feature between relations and functions is you have to ask yourself, does it have repeating x values? If it has repeating x values, it is not a function. Does it pass the vertical line test? If it does pass the vertical line test, then it is a function. And a function is usually patterned with a rule or an equation, and that's what we're going to be reviewing today with the function notation and the graphs. So remember, defining a function means it will not have repeating x's, it will pass the vertical line test, and it's probably patterned with a rule or equation. So on 2-2, characteristics of relations and functions, we're starting with number 3 because I shortened the assignment last Friday. And again, if you looked up function notation in your vocab and you got that done, you're running right on time. If you haven't done it yet, try to get it done so you're not too far behind on our class. Function notation. Remember we said, a lot of you just wrote down, it's a fancy way to say y, and that's true. So we would say x, comma, y is also written x, comma, f of x. And we use that because there might be several different functions we're working with at one time. So if we call f of x the Fred function, and you could have a different name like g of x, which would be the George function, or h of x, which could be the Hilda function, and they could all relate to something in a word problem about Fred, George, and Hilda. Now we'll get into verbal problems and word problems later on in the year. Right now I just want you to be familiar with they can be written in this format. We're going to practice with input on the calculator. So number 3, you're going to find the f of 4 and the f of -1. Remember, the 4 is the input and the -1 is the output. So using your calculator, your key sequence would go 2 parentheses 4 close parentheses plus 3 enter. And the reason I'm telling you to do this is because I just want you to remember the calculator does not know PEMDAS. If you were to put in 2 times with the star 4 plus 3 and then enter, you might get the right answer and you might not. It all depends on if it's in the correct order for the calculator to read it for PEMDAS. So if you were to do it this way, you might get the right answer, you might not, but you'll always get the correct answer if you put it in with the input in parentheses. So maybe a couple extra keys to press, but I know you can handle it. You also are very advanced with the calculator. Y'all are awesome class. And you could also put it in y equals and put in y equals 2x plus 3 and enter. And then you would just go, that second graph takes you to a table, and you would scroll through and find your values for 4 and -1. And so then your input would be 4 comma something and -1 comma something, And y'all can do that now. So I'm trying to keep this short and sweet to just give you some hints because I don't know who my sub is and how much they know about the calculator or how much they know about math. So I didn't want to leave y'all hanging as much as you wanted a free day. I know. So number 4, be sure and plot the points labeling the axes that are given. And your hints I'm going to give you for A, it says identify the domain. So you would put D colon, and looking at those points, you would list all the x values. Make sure there's a comma between each one. On B, identifying the range, you would put R colon and list all the y values out the same way with commas in between. On C, you would answer the question, well, does this, looking at the graph or looking at the coordinates, the graph, what you would check, does it pass the vertical line test? Looking at the coordinates, you would want to see if any of the x values repeat. And on D, it asks if it's continuous or discrete. I know I wanted to wait on that vocab word until today, so I'm going to kind of give you some hints on it before we do it this afternoon. Basically, continuous or discrete. I want you to answer the question, can the points be connected because there's a pattern? And if the points can be connected, then we would call that continuous. And if it's continuous, it is connected together. We could find values between each point. Looking at this set of coordinates, I don't believe there's any way to connect them. So, answer the question, continuous or discrete, and explain your reason. On number 5, let's look at these functions. We're going to start on the left side, and you read these functions left to right on the graphs. So if we look at that zigzag function, it's got an open point on the x-axis and it's got a closed point on the x-axis, and that's how we're going to read our domain, because our domain is the x-axis. So we look at our domain, and to the far left we see a -2 value, and the far right we see a +4. But the -2 is not closed in, so we say that's open, and we would keep that less than. But on the far right we have a +4, and it's filled in, and that would be a less than or equal to, so make sure you put the line underneath there. For the range, we're looking at the up and down values. So look at the smallest value, and that is a filled in dot, so that's going to be less than or equal to. And then the upper value, the maximum value, that's also filled in, so that's going to be a less than or equal to. Fill in those values as best you can. Then answer your question, is the relation also a function? And you would say, does it pass the vertical line test? Does it have repeating x values? On continuous or discrete, I'm going to give you a hint. Ask yourself, is the data connected? Are there values between the points? And if there are, then it's continuous. So the next question, on what intervals is it increasing? Look at your x-axis, left to right. There's 2 intervals that it's increasing, and that would be, I don't have room to write it down, but that'd be from -2 to 0, and that would be from +2 to 4. Now fill in your decreasing intervals, knowing what you know about the increasing intervals, and go on to the next function. It's tricky, but the sub can help you with some hints. In an effort to get this final activity concluded, I'm giving you the helpful hints on the key sequence for the calculator, and go ahead and try to do both problems. We'll go over those tomorrow if you have any questions. And be sure and do your vocab for tomorrow. Those would be the words continuous and discrete. Look those up in the book, and you can just draw a picture if that helps you a little bit better. I hope that y'all have a good afternoon, and I'll see you tomorrow.